All right, folks, let's kick it off then. Welcome to our August 2025 meeting of the Central Florida Astronomical Society. I am your host and president, Frank Kane, with you yet again for another exciting, fun-filled meeting full of stuff, and we'll talk about that stuff in a minute. But if you're watching this and you're not yet a member of Central Florida Astronomical Society, you may be asking yourself, why would I want to join? Good question. I just happen to have some answers for you. So, among the many reasons are the access to our private events and dark sky viewing locations. We have a dark sky site out in Geneva, Florida, where we gather whenever we can, whenever the weather permits, and get out there under the stars with our fellow members and teach each other about our telescopes and share the views of the night sky out there. We also have a very vibrant loaner telescope program for members where you can actually borrow a telescope for a period of time and get the hang of it and get a little bit of training on it. And more recently, we're going to talk about this a lot tonight, a new remote observing program where you can actually book some time on a remote telescope, a sea star specifically, out in Texas at the Starfront Observatory out there, which is really cool, especially because here in Florida, the skies don't always cooperate. So especially in the summer, it's often cloudy, it's stormy season, so it's good to have a backup location that has drier weather, and we offer that for members as well. We also have a vibrant online community at cfas.groups.io, where you can communicate with our fellow members of, gosh, close to 250 people now these days. 230 something or other, I think, is the official count right now. Also, you have access to our quarterly in-person meetings at the planetarium at Seminole State College. How cool is that? And also, your membership includes membership in the Astronomical League, which is a nationwide consortium of astronomy clubs, if you will. That includes the receipt of the Reflector magazine once a quarter as well. We are a nonprofit 501c3 organization, 100% volunteer powered. None of us make any money off of this. Every penny of your dues goes toward our mission, so you can feel warm and fuzzy about joining. And what's more, you get discounts on Astronomy Magazine and Sky and Telescope Magazine if you are a member of CFAS. If you're interested in joining up, head on over to cfas.org, and you can learn more about our plans there. Tonight's main speaker is Ken Ruffin, and we are trying to track him down right now.
He's here.
Oh, there he is.
Yeah.
Hey, you're here. Thank you. Yay.
You might
Cool.
need co-host privileges.
I am going to co-hostify you right now, Ken, so you can share your screen and whatnot. And Ken's going to be talking to us about Near Earth Asteroids and what can we do about them? Are we really better off than the dinosaurs were? Well, I certainly hope so. We're going to talk more about that tonight. Following Ken's presentation, we're going to have the usual club news, and there's a lot of it this time, so do stick around for that. Usually August is a slow time for the club, but not this year, folks. There's a whole lot going on, and I can't wait to tell you about it. And we also have a very vibrant astrophotography showcase where members will be showcasing their astrophotos and sketches as well after all that. And again, for August in Florida, you wouldn't expect there to be much, but we have quite a few good submissions to go through at the end there too. So do stick around. And I want to welcome our main speaker tonight, Ken Ruffin. We have a little bio here that I'm going to read here. Since 2011, Ken Ruffin, a former aerospace engineering student, has essentially been the president of the National Space Society of North Texas, NSS-NT, presenting to well over 200 audiences on present and anticipated space missions to attendees of all ages. Ken has launched NSS-NT to earn the NSS Chapter Leader Award 6 years, as well as to earn the NSS Excellence in Public Outreach Award 7 other years, therefore earning either of the top 2 NSS Annual Worldwide Chapter Awards beginning in 2013 inclusive. Also, Ken was awarded the NSS Chapter Leader Award in 2018 and in 2023. Additionally, Ken has been reelected to the NSS Board of Directors, he has been appointed to the NSS Board of Advisors, and he is an active NSS Space Ambassador. Last but not least, Ken contracts with organizations within and adjacent to the space industry, providing outreach to inform the public about the products they develop and or the services they provide. Welcome, Ken. Are you with us? You might be muted.
Okay, yes,
There
I'm
you
here.
are.
I just had to unmute first.
Okay, cool.
Thank you guys for having me.
Let me unshare my screen. And my understanding is that you want a interactive presentation tonight, right?
Yeah, that would be great. And I don't know the routine if people typically would ask questions through the chat. Um, I would imagine that would be the most comfortable for me, sort of the least distracting.
Sure.
I just may or may not catch every question as it appears. So if you could help me out with that, that would be great. Or if someone could help
Absolutely.
me, that would be great.
Yeah, I'll keep an eye out and kind of butt in if we have some good questions that are relevant. But yeah, folks, bring up your chat window right now. Down at the bottom of the screen, you should see a little chat icon there. So if you have questions as we go, punch them in there, and we can either get to them in real time or at the end of the presentation, whatever you want to do. And do remember to stay muted, however, if you're not actually asking a question right now. We don't want to hear, the TV show in the background or whatever's going on there at home. So just a little bit of housekeeping there. But yeah, welcome, Ken. Thanks for joining us tonight.
Yeah, yeah. Thanks for having me, and thanks to Sharif in particular for the invitation. So
Absolutely.
I'm honored to be here.
Cool. All right. To get some slides tonight, or how's it going to go?
I do.
All
I
right.
certainly do. All right, so I that's my cue to start sharing.
Yeah. And by the way, the
So
National Space Society is headquartered right here in Central Florida. Am I right? So out at Kennedy Space
that's
Center.
correct. Yes, yes, absolutely. So yeah, and even though the name of the organization is National Space Society, we are actually an international organization, just for the record. And
Cool.
yeah. So, and there are chapters of the National Space Society across the U.S. and around the world, including the chapter in Florida, which is called the Florida Space Development Council, and
That's right.
it's based on the Florida Space Coast.
Yep. Yep. I know where that is. Cool. Yeah. And you guys have the coolest magazine, by the way, as well, at Astra. I love that one. So I look forward to
Oh,
that in the mailbox every quarter. But
oh, great. Oh, so you're a member. Oh, that's excellent.
I am. I'd say
Okay.
card carrying, but they don't actually have cards. But yeah,
We used to. That was an old school thing. So
that's right. Yes, we look to the future in the National Space Society.
yeah, absolutely.
All right. All right, let's kick it off here. So I'm seeing your presenter view here, I think.
Okay, great. So wanted to make sure that was working properly before I fill the
There we go.
screen. Okay, great. So if that's my cue, I'll begin.
Take it away. Thank you.
All right. Thank you. And welcome everyone who's watching live and at some point look watching the video. My name is Ken Ruffin. I appreciate the introduction, Frank, and glad to be here tonight to talk about near Earth asteroids. What can we do about them? So I will give everyone a heads up. There's a fairly lengthy introduction. I've created several presentations through the years, and this one has the longest introduction. But personally, I think this is also perhaps the most interesting and most fun topic. So there's a lot of background. Some people may be familiar with some of the points I'll make, some not so much. And I'll let everyone know in advance. Excuse me. Most of what you're going to see overall are going to be photographs, images, and graphs. So there's not going to be, a huge amount of text. There's going to be what I call pretty pictures. All right, so here we go. Table of contents. I can't get tongue tied on the second page. Introduction. Uh, then part one, finding the asteroids. Part two, studying. Part three, protecting us from asteroids. And part four, last but not least. And then finally, some very brief conclusions. So here's the intro. When many people think of the asteroids, they think of the asteroid belt. I've actually had conversations with people in the general public where when I mentioned near Earth asteroids, and they corrected me and said asteroid belt. And no, I'm not talking about the asteroids between Mars and Jupiter. I'm talking about asteroids you may hear about on the news from time to time that literally pass near the Earth. Now, there may be billions of asteroids in the asteroid belt itself between Mars and Jupiter. But again, the purpose of this presentation are those approximately 1 million near Earth asteroids. And by definition, those are asteroids between 1.3 astronomical units or uh, between the distance of the sun and 28 million miles beyond Earth's orbit. Um, those are near Earth asteroids. Now, some of their orbits may extend to the asteroid belt. Some are just within the inner solar system. It really varies, and with there being so many asteroids, there's just lots of variety, lots of options. Okay, now people commonly will talk about meteoroids, meteors, or meteorites. those are what I call Earth-centric terms. Those were terms that have existed for for centuries, for millennia perhaps, before people were aware that asteroids even existed, and um, let alone near Earth asteroids. But those meteors, and meteorites are actually um, near Earth asteroids, or pieces, rocks or pebbles or grains of sand or dust from near Earth asteroids. So you can see the four different types. The two that are bolded are asteroids that cross the Earth's orbit, whether the majority of their orbit's inside Earth's orbit or the majority's outside. They cross the Earth's orbit. So those are the ones most likely in general to be considered a potential threat because they cross the Earth's orbit. The good news is they don't normally cross the Earth's orbit while the Earth is in that location. So the Earth's orbit's really large. It's 93 million miles radius times pi. You're welcome to do the math. It's big. All right. If anyone's familiar with the TV or former cable TV series Meteorite Men, this gentleman, Jeff Notkin, was a co-host of that series, and he's also on the board of governors, as you see here, and a friend of mine. All thanks to NSS, the National Space Society, that we've been discussing here. So he's been at several of the annual space conferences, and you'll hear me make a couple of references to the annual space conference through the years. All right. So here's one of my busiest slides: near Earth objects. That includes near Earth asteroids and comets. So we're just over 39,000 of those asteroids and comets that have been identified and their orbits have been tracked. This is as of yesterday. Now, I pride myself in trying to provide, as often as possible, the latest information in space travel. So I truly love being able to give a presentation when I can say this was the most up-to-date information as of yesterday, not 10 years ago, not 10 days ago, yesterday. So you can see the stats, you can see the website, the official NASA website for not just that information, but you can spend all day going through all the information available. Now, potentially hazardous objects or potentially hazardous asteroids. You'll hear PHO or PHA within this presentation, and similar maybe documentaries you might come across at some point. Those pass within 4.65 million miles of the Earth's orbit, and that might sound enormous, but it's about little less than 20 times the distance from the Earth to the moon. Potentially hazardous asteroids. They cross Earth's orbit, and they can pass close enough to the Earth so that the Earth's gravity might change their orbits. So they have to be tracked. All the asteroids that have been discovered are tracked, but these in particular are tracked more closely because, again, if they pass by the Earth, their orbit's likely to change, which may or may not change the likelihood that at some point in the future, because there are computer models that run for the projecting for the next 50 to 100 years as to whether or not an asteroid is predicted to hit the Earth. And these models are getting better and better. When I first heard about them, the projections were for the next 20 years, and now they're up to 100 years. And currently, good news, zero asteroids are predicted to hit the Earth. Zero known asteroids are predicted to hit the Earth in the next 100 years. Now, here's a little pop quiz. On the very top line here, below introduction, you'll see 39,000 plus. So let's round it out to 40,000. Let's round up. 40,000 near Earth objects have been detected. That's out of a population of 1 million near Earth asteroids. So if you do the math, that's 4%. So I'm guessing, pop quiz, but don't answer. I'm guessing nobody's ever received a 4% test grade on, for an actual test that they took in school. If you did, don't admit it. that is the grade that the worldwide combination of astronomers have received for finding near Earth asteroids, near Earth objects. 4%. So, not great at all. In 1898, at the bottom of the screen, that bottom section, the first one was discovered. First potentially hazardous asteroid, Eros, 1898. So in 2013, which was when I initially made this presentation, and I've updated it over a dozen times since, um, an additional 1,383 more objects or near potentially hazardous asteroids have been discovered. And since then, over 1,000 more have been discovered. So the rate of discovery is definitely increasing, but we're still only up to 4%. So something's got to be done. We'll get to that.
Yeah. Hey, Ken, we got a
So,
few questions coming in if you want to take them.
oh, sure, let's do that. I'll go back.
Yeah, so first of all, Luke says your audio cut out when you were getting to that 4% number. It came through for me, so Luke, that might be on your end, but just for his sake, do you want to kind of reiterate what that 4% number represents?
Sure, sure. And I'll get a little bit closer and maybe that will help. So, 4%, the number of potentially hazardous asteroids or near Earth asteroids that have been discovered compared to they're not potentially hazardous. The number of near Earth asteroids which have been discovered compared to the number which we believe or scientists believe actually exist. So scientists worldwide, the worldwide combination of their efforts in all these years, we have found 4% of what we believe are out there. We found them and we're tracking them. We know that they're not going to hit us, which is good news, but we've only found 4% of what we believe the total to be.
Right.
It's it's actually kind of terrifying if you stop and think about it. So don't stop and
Mhm.
think about it. There's a plan to make things better.
Well, you might be getting to this later on, but there's a distribution of like sizes. So we think we found most of the really big ones by now, right?
I'll get to it. You're
All right,
absolutely
cool.
right.
And I
Yeah.
think you might be getting to these other two questions as well. Matt
Okay.
is asking, has this number been updated due to some of the big telescopes that have been coming online lately, like Vera Rubin?
Has it been updated as of August 19th, 2025?
Okay. And is a lot of that being driven by new telescopes coming online? Like,
Absolutely.
cool. Cool. And Mosimo is asking, I'm pretty sure you're going to get to this question later on, but if we did have an asteroid that we knew was coming at us, what can we do about it, right?
It,
Do we have to send a
it
rocket there? Like, what do we do?
I'll get to that also.
Thought so.
I'm tempted to just say run, but
Dig a hole. Yeah.
there's a better plan than that.
All right.
Okay, but good questions, and the answers are coming. The purpose of this introduction is to make sure people are paying attention, and I think I've accomplished that.
Oh, yeah.
So
We're a
yeah,
lively
so
bunch.
yeah,
All right.
so thanks to everyone for those questions. All right, Tunguska. Now, that's the name of a city or area in Russia where way back in June 30th, 1908, there was an near-Earth asteroid came through the atmosphere and there was an airburst. That's one of the terms that are used. Sometimes people want to correct me when I say airburst. Bolide is another term. The list goes on and on and on. The asteroid, due to the shock wave created and the friction with the atmosphere, the asteroid exploded, and what looks like what might be broom straws lying on the ground, those are actually trees. So the force of that explosion leveled part of a forest for a number of acres back again, June 30th, 1908. So this is an actual photograph. And of course, there's one tree that's left standing. There's always got to be one. So in any situation, any given, there's always going to be one that stands out, being different. It didn't follow the program. All right. So June 30th, the United Nations recognizes June 30th as Asteroid Day because of Tunguska, and it's also my birthday. So it's a double celebration that, well, the United Nations should recognize both, but I recognize both. So as the news media has been reporting through the years, through the decades, every so often, here's yet another asteroid that has passed so many millions or so many thousand miles away from the Earth. Sometimes they say that the asteroid is going to pass by the Earth, in a couple of days. Sometimes they say the asteroid passed by the Earth a day or two ago, and we didn't find it until after it passed by. And I don't know if anyone else has been seeing or hearing about things like that, but in just the general news media, this is something that has happened literally for decades. And the one major event I would say, since 1908 was on February 15th in Russia, the morning of the 15th in Russia, the night of the 14th in the United States, Valentine's Day in the United States of 2013, over the city of Chelyabinsk. And I don't know if anyone remembers that, um, but whether or not you remember, I've got pictures. So 9:30 a.m. on a Friday morning in the city of Chelyabinsk in Russia, people were going to work, students were in school, and all of a sudden, without warning, here's a photograph of this bright, blinding white light. I read somewhere it was described as being 14 times brighter than the sun. And if you can imagine, you're going to work, minding your own business, or you're at work, or you're at school, and all of a sudden, something brighter than the sun is in the sky for a few seconds. And it was that asteroid exploding. And here's another photograph of the trail that was left behind from that same asteroid. And at the bottom of the photo, you can see those buildings representing the city of Chelyabinsk. And here are some people to scale where just one small chunk of the asteroid crashed into a frozen lake. Frozen lake. Again, February in Russia. And you know, lakes were frozen. They retrieved the chunk of the asteroid that left this hole, and everyone was fortunate that there were no fatalities. As the asteroid went through the sky, as it exploded, as it was extremely, bright, as I mentioned, there were shock waves that were created from the explosions. And when the shock wave reached the ground and the speed of sound from, speed of the shock wave is a lot slower than the speed of light. So about 30 seconds after the blinding white light is like streaking across the sky, people are standing at their windows, looking, wondering what's going on. And next thing you know, the glass implodes like in buildings and houses all over the city. So about 1,500 people were sent to emergency rooms to have glass removed from the fronts of their bodies. And in some cases, there were roof collapses. So there were injuries due to that. It was not a great day to be in the city of Chelyabinsk in Russia. But again, fortunately, everyone survived. No fatalities. Um, but lots of cuts and bruises and um, temporary blindness, even that people experienced looking at the blinding white light. So if you're ever in that situation where there's a blinding white light going across the sky, turn your back to the windows and go away from the windows. Seek shelter indoors. Seek shelter, um, like you would if it was a tornado. All right, so here are the stats. That Chelyabinsk meteor weighed about 10,000 tons. It was only about 55 feet in diameter, and it was traveling at, about 40,000 miles per hour. And the explosion intensity was that of, I skipped the altitude, about 14 miles altitude, and energy release of 500 kilotons equivalent of TNT.
Wow.
So yeah, that was, and I have to say, with all the details I've given, with all the pictures you've seen, nobody saw this coming. No scientist anywhere on Earth had any idea that this was going to happen.
Yeah, and Isabel's asking why not. Maybe you're getting to that, but how did we miss this one?
We missed it because coincidentally, well, two reasons, three reasons. Asteroids in general, the reason why they're so hard to find, and we've got all these telescopes, and we've only found 4% of what we believe the total to be, statistically speaking, asteroids are almost jet black in color. And space is, guess what? Jet black. So if you've got um, for example, 40,000 mile per hour object that's jet black traveling against a jet black background, it's really hard to see. And 55 feet in diameter. By space standards, it's about as small as you can get. And it was coming, to make matters even more complicated, to make it worse, it was coming from the apparent direction of the sun. Like that morning, it was coming from the east, and the sun rises in the east. So um, everything was, all factors were working against finding this asteroid before it was coming through the atmosphere.
Wow. Another thing that kind of sticks out to me here is that this thing blew up 14 miles up in the sky. So
Mhm.
your survival tip there might actually work. That'd be a pretty good delay between seeing the flash from that and actually being hit by the shockwave from that, I would think.
Well, this is one example. This is
Mm,
only one situation where the asteroid just happened to come through the atmosphere, essentially parallel to the ground. I'll go back up. Um, Pixar, it didn't happen, right? Essentially
yeah.
parallel to the ground
Mm,
until gravity and the atmospheric friction slowed it down enough so that, a piece landed in the lake. But it did not have to come through the atmosphere at this angle. It could have
right.
come straight down into the earth, and there would not have been any explosions until it hit the ground and left the crater.
Right. Yeah.
And
So
yeah,
got lucky that time. Well, lucky in quotes.
yes,
Um,
yeah. By the standards of what could have happened, this was the absolute luckiest scenario possible.
right. And speaking
Now
of being
the people who went to the emergency rooms may not agree, but overall, yeah, that was
for sure.
as lucky as they were going to get under the circumstances.
Right, right. And from the unlucky side, most asking, how big does an asteroid have to be before it would be considered to be really cataclysmic? Are there like different levels of badness there that we kind of define or
hmm Um, there, see, cataclysmic is relative. To the people who went to the emergency rooms, they might have thought this one was cataclysmic. The United Nations defines asteroids large enough to be considered a threat as asteroids that are 140 meters in diameter or larger. So that is basically 8 times the diameter of this one. But there are countless asteroids, literally, in sizes between this one and 140 meters. This is only 17 meters. 140 meters, you're talking about an American football field and a half, approximately. This you're talking, something between you're talking the 0 to 20 yard lines on a football field, or the 20 to 40 yard line. You're talking in between those yard lines that go all the way across, as opposed to a football field and a half.
Mhm.
And then, of course, they get much bigger than a football field and a half. And I'll talk more about that. Um,
Cool.
this is mind blowing stuff for me, and I can't even tell you how many times I've given a presentation. It still blows my mind. The same day that the Chelyabinsk incident happened, what's the red line here, which is listed as impactor, there was another completely unrelated asteroid named 2012 DA14 that we knew was coming and just happened to pass safely by the Earth that same day, February 14th, Valentine's Day, 2013. So that was an extremely interesting day um, in the for people interested in near Earth asteroids, and I just happen to be one of them. Let alone people who work for NASA or various other organizations that actually track them and deal with them. So what are these asteroids made of or how are they classified? Most of them are what's called ordinary chondrites, about 80%. Um, that means they're basically made of sand, and the sort of rocks, the sort of materials that you would generally expect to find on Earth, just like on the ground, without having to mine for anything unique or special. But there are asteroids that are primarily metallic. There are asteroids at the top. They're carbonaceous chondrites. They have a percent. They have carbon, and they have a percentage of water bonded with other minerals. But most of them are basically like big, your big. I don't want to say generic rocks because that's not a scientific term at all. But made of silica, which is sand. So this actually this is indirectly related to one of the questions I was asked. Um, this is the how many of I'm sorry, how big the asteroids are, how many of them are that size, and a question that did not come up, how often are they likely to pass by the Earth? Well, let's go just a little higher than the middle, and up to the right, 1 meter diameter, so a little larger than a yard. On average, an asteroid impacts, not passes by, but impacts the Earth once a year. But the good news is, because you probably never heard of that happening, the good news is at that size, 1 meter, a little over 3 feet, the asteroid burns up in the atmosphere. So though that would be like a really bright um, shooting star, if it happens at night. So there's that. But then the next one, the 100 meter, there's your football field size every 10,000 years. However, there's a lot that's not shown on the scale between 1 meter and 100 meters. So I don't know if that was avoided intentionally, but this was the best data I could find related to size and how often they impact the Earth. Now, truly catastrophic. Now, that's your dinosaur killers. There's your Chicxulub event from 65 million years ago, 10 kilometer or about 6 mile diameter, on average once every 100 million years. So it's been 66 million since the last one. Statistically speaking, we've got, about 34 million years until the next one. But again, there are many, 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 many asteroids smaller than that, which can still do significant damage.
Yep. If I could interject with a couple of questions here.
Sure.
So Luke has a really good one here. So, we talked about an estimate of 1 million near Earth asteroids earlier.
Hmm.
What range are we talking about in terms of size for that set of bodies? Is that
Oh,
kind of
that's
getting to the,
all sizes. The 1 million, that's all sizes. That's from um the largest near Earth asteroids, and I'll get to that, but I'll just go ahead and tell you they're between like 6 to 12 miles in diameter. Those are the largest ones. And that's all the way down to boulder size.
okay. So it kind of gets down to like the distinction between a meteor and an asteroid, right? Like there's what exactly is the difference? How do we distinguish between those two?
Perspective. The
Hmm.
term meteor was established again hundreds or thousands of years ago before anyone knew that asteroids existed. So, from a standing on the ground looking up at the sky, from an astronomy perspective, you think in terms of meteors, meteorites, something coming through the atmosphere that may or may not hit the ground. But those before they're at the point where you see them coming through the atmosphere or before they hit the ground, they were near Earth asteroids, or they were rocks that came off near Earth asteroids.
Right. Yeah, I
So it's
always mix them
kind
up.
of the same thing.
Yeah, meteoroids, I think, are the ones that are not in the atmosphere. Then it's a meteor, then it's a meteorite. If I remember, I
Yeah,
don't know. It always
yeah,
messes me up.
yeah, that's
Yeah.
it. And so if it's not in the atmosphere, it's, from my perspective, clearly a near Earth asteroid. It's
Okay.
still in space.
And John Pinto's asking, what about comets? Are we lumping those in with this discussion as well? Is there a distinction there?
Yes and no. Is there a distinction? The distinction is this is I often get this question and I always hate that I have to answer it, but I have to. Um, Comets are usually excluded from, well, first of all, they are different. I need to just define. Asteroids are typically made up of, I was talking about silica like sand, and metallic, carbonaceous, so on and so forth. But comets are mostly ice and rock, and they come from farther out in the solar system, whether they originated in the Kuiper Belt beyond the orbit of Neptune, and the most famous member of the Kuiper Belt is the former planet Pluto. So they either come from the Kuiper Belt or they come from even further out, the Oort cloud, about a light year away from the sun. So in either case, because they're so much further away from the sun, if they originate at that either distance and come towards the sun, passing by the earth so that we can see them, they are traveling much, much faster than any asteroid.
Mhm.
Um, Traveling much faster, much more energy, and the reason why they're usually excluded from these conversations, especially if you're leading up to what can you do about them, like the name of my presentation, comets come so quickly, there's nothing that has been conceived using technology we have or technology we may have, nothing we could do to deflect them because of the combination of their mass and their velocity. Um, they'd be unstoppable.
Mhm. That's
So,
actually, yeah, that's a good answer. Like I usually hear like the distinction, like in terms of their composition, like, comets are ice balls, but that's not really true. They're made of rock too. It's more
yeah,
about their origin and their velocity and where they're coming from. So,
exactly.
yeah, that's
Exactly.
cool.
So if you're like in this case, in this presentation, I'm leading up to what can we do about them? Comets, not so much.
Hmm.
Can't do anything. You run,
That's too
run,
bad. Yeah.
and run faster.
Yes, become a mole person. We
Yeah,
also have a question from Mosimo asking about asteroid mining. I don't know if you want to save that for the end, but what can we get
yeah.
from
Let's
asteroids?
save that.
All right,
Let's save
yeah.
that. I've got a section on asteroid mining. So
Oh, cool. All right.
yeah.
Carry on. Thank you.
All right. So, and I really do need to go quicker because I'm having too much fun with this. So, the smaller the asteroids are, the more of them there are, and this is asteroids like including the asteroid belt, as well as near Earth asteroids. So, 1 million, I'm sorry, 1 meter. So you're talking a little over a yard. And then let's say you go up to 100 meters, um, total near Earth population. Oh, this is an old graph. I do need to say this. This graph, or this table, I'm sorry, this table um, does have some outdated information, but I save it just to give an idea of perspective. Like the first three rows, you go all the way across to the right. Crater diameter, no crater. Um, 1 meter, they'll burn up. The hope is even at 30 meters, which is about 100 feet, that it would burn up in the atmosphere. That's the hope, but really it depends on the angle. It depends on whether or not they're made of sand or whether they're made of iron. If it's iron, it's not going to burn up. It will leave a crater. Um, Skipping down to the end, 10 kilometer or 6 mile and larger, there have been four that were discovered when this table was made many years ago, and even as of June, a couple of months ago, when right before I gave this presentation at the International Space Development Conference. Um, that's that number four is it still stands. And if there was another asteroid, near Earth asteroid discovered, more another one that's more than 10 kilometers or 6 miles in diameter, it would be all over the news. Whether or not there was any risk of it hitting the Earth, it would literally be all over the news and would stay there for a while. So, fireballs reported. These are asteroids that entered our atmosphere and burned up, and they were detected by, it says, US government sensors. These sensors were not developed to discover fireballs, not for near Earth asteroids burning up. They were built to detect nuclear explosions. And since these sensors were established, there's a network, all over the world. They have detected zero nuclear explosions, but as you can see here, there have been hundreds of near Earth asteroids coming through our atmosphere and exploding. Most of them, because approximately 70% of Earth's surface is covered by water, most of them have been over the oceans. However, you can see quite a few over land. And the one that may stand out, there's a red circle near the top and right of center. That was Chelyabinsk in 2013. That was the biggest one that's been detected by these sensors since 1988. All right.
Yeah, Isabel has a quick question on that one.
Oh,
So,
sure. Sure.
yeah, maybe it's just random chance, but it does seem like an awful lot of the high energy ones are near the equator for some reason. Is that a coincidence or?
That's a good question. That's a question I don't know the answer to, and I can't remember the last time that's happened. I'm I'm gonna jot that down, um, and just find the answer and send it back to you guys after the meeting. So um, that's an
Well, it says
excellent
maybe it's just a
question.
map projection. That's
You know
actually,
what?
yeah.
But I do have I don't want to call it a theory. I'm going to speculate because this is a two-dimensional representation of our three-dimensional Earth,
Hmm.
because I do want to clarify the Earth is not flat. Okay. So because of that, because you have more land area literally around the equator than you would have
Hmm.
available at the poles, then, statistically speaking, you would expect a larger concentration because even though it doesn't appear to be the case looking at this two-dimensional map. In three dimensions, if you think of a globe, there's a lot more land area around the equator, land and water area. There's a lot more area for airbursts and fireballs around the equator than over the poles. So although I'm
Right.
speculating because I haven't read that, I'm really confident that I'm correct. And if anybody would like to disprove that or has information to disagree, please let me know.
Yeah, that definitely holds up. We've had some other speculation in the chat here too. I mean, one good point is that the Earth does spin faster at the equator, so maybe that increases the velocity relative to some of these objects. And maybe it's because a lot of objects are in the same plane of the solar system. Although I would think that Earth's tilt would kind of make that not so of a tidy explanation.
Agreed. That 23 and a half degree angle. Yeah, that's a good point. That's a good guess. The Earth being in the ecliptic, the
Hmm.
plane coming from the sun's equator. But yeah, I think because of Earth's tilt, I think it's more likely thinking of a globe. You've got so much more land and water area at the poles than you do. I'm sorry, at the equator than at the poles.
Yeah, for sure. That's part of it. Cool.
Now,
Thank you.
would you believe this is the end of the introduction?
All right. We'll let you go. Right. Go, go, go.
And this happens every time. Oh, well, this is the end. So there's an asteroid, 2016 HO3. I promise this is the last page. It has sometimes been described, especially when it was discovered 9 years ago, as Earth's second moon. But it's not a moon because it orbits, as you can tell from here, it orbits the sun. But as it approaches the Earth, it makes a loop around the Earth and then continues to go around the sun. So this is not like a spirograph drawing. If there's any old school folks who remember the spirograph toy, or maybe it still exists, I don't know. This is a plot of the orbit of what is sometimes called Earth's second moon, but it is not Earth's moon. It is a near Earth asteroid. Now, part one: finding near Earth asteroids. So, various telescopes, and this question came up earlier. Various telescopes, and they're color coded here. They started this particular chart starts with 1995, tracking near Earth asteroids with one set of telescopes, and there have been many other sets. You see the names of the telescopes listed on the right. And the general trend is each year there's an increase in the total number of asteroids, near Earth asteroids, NEAs. How about I call them that? NEAs, which have been discovered. Now, 2025, we're just in August. There's a lot of time left in the year. So the expectation is we'll continue to find asteroids at the same rate. So by the time the year is over, we should have found over 3,000 asteroid 3,000 NEAs this year. Now, this is a good bad table. As far as the estimated diameter, this is in meters. And when I see meters, I think in terms of football fields. Let's start with the far right. 1,000 plus meters. That's 10 approximately American football fields and larger. So 876 have been discovered. And coming back to the left, and yes, this is backwards, but it's for a reason. There's a method to the madness here. So you can see the numbers. The smaller the diameter of the asteroids, the 3 to 10 football fields, we found over 5,000. 1 to 3 football fields, we found over 8,000. That trend is increasing. Here we go to 30 to 100 meters. So from a third of a football field to a football field, we found 13,000. Then all of a sudden, there's a drop, and that may or may not look unusual. Well, it's because the smaller they are, again, the harder they are to find. Something jet black moving against a jet black background at tens of thousands of miles per hour. So that smallest size category, that's where the majority of the asteroids are, in that category. But we found very few of them because they are the hardest ones to find. So if you feel just a little bit terrified, you're in good company. Oh, and as far as the date, because I was asked before about, is the information up to date? This is as of today, ladies and gentlemen. And the website is on the bottom left there. There's an organization, another nonprofit called the B612 Foundation, dedicated to defending Earth against asteroids. Their original goal was to have fundraising to build and launch I should say, build and launch an infrared space telescope to find near Earth asteroids. They were not able to raise the money, sufficient money at the rate that they wanted to, so they changed their plan. But first, the gentleman in the middle is Dr. Ed Lu, former shuttle astronaut and founder, um, I'm sorry, CEO of the B612 Foundation. So that's him in the middle with some of my National Space Society of North Texas chapter members. And here is the president, next to me, Danica Remy, president of B612 Foundation. So two different occasions I've met, and some of my other chapter members have met executives with B612 Foundation. So their new plan, instead of building infrared space telescope, they have a two-step process. They're using what you see here, Adam and Thor. They are using a supercomputer to go through photographs to go through like millions of photographs and of the night sky to find near Earth asteroids in photographs that have been taken of the night sky for some other purpose. But the supercomputers are programmed, or at least there's a specific program for the supercomputer for finding near Earth asteroids, and that's the Atom project using the Thor algorithm, and it's been quite successful. Um, well, it's been somewhat successful. I'll put it that way. It's definitely been working, but again, this has contributed to the total of us finding 4% of the total. So they've helped get the number up to 4%. Also, The second part of their plan is to use a large new telescope run by the University of Washington in the state of Washington, the LSST, to find, it's on the top of a mountain, and using an infrared telescope to find near Earth asteroids. So a combination of both the supercomputer and the algorithm, as well as this telescope. So that's what I'm explaining here. Also, NASA has proposed for several years, and they've had a plan, and then they changed it. They had another plan and changed it. And every time they had a different plan, it's had a different name. Well, now this is round 3. NEO Surveyor is the latest proposed NASA infrared space telescope, which will be located, fingers crossed, at the Sun Earth L1 point. What does that mean? L1, Lagrange point number 1. There are 5 points when you're looking at the sun and the Earth, and how the Earth orbits the sun. There's a point L1 between the Earth and the sun. It's about 1 million miles away from the Earth, and therefore 92 million miles away from the sun, for a total of 93 million miles, where the telescope would be facing always away from the sun towards the Earth and the area around the Earth to look for near Earth asteroids. Now, it will have a sun shield, and it's scheduled to launch NET no earlier than, and that's always the case. It's always the case for rocket launches, September 2027. Launched by, if you follow rocket launches, you won't be surprised that it's a SpaceX Falcon 9. It's been the workhorse, not just for launching from American satellites, but American space probes and other space probes from countries around the world, other probes, other satellites, you name it. So the plan is for it to carry at least a 5-year survey to try to find objects as identified by the United Nations larger than 140 meters or 460 feet. But as I pointed out earlier, as the Chelyabinsk incident proved, it doesn't have to be anywhere near 460 feet in diameter to cause damage. But we certainly need to find at least 2/3 of objects larger than that size. And not just finding them, but finding their composition, the shapes, rotational states, and orbits. The survey director for NEO Surveyor is Professor Amy Mainzer, and I had the privilege of meeting her several years ago at the National Space Society's annual conference, the International Space Development Conference. I think that might have been 2014-ish. It's been at least 10 years. So, part 2, Near Earth Asteroid Exploration. So this is artwork, not an actual photo. But these are actual photos, and I have to give credit to the Planetary Society for this um, for this combination of actual photos taken by various spacecraft, comparing mostly asteroids and a comet or two, comparing them to scale. And let's see, there's a couple that are really, really interesting that I want to point out. On the near the top right-hand corner. Okay, at the very top right-hand corner is Dactyl. You may or may not even be able to see the asteroid itself, but Dactyl's at the top. But below that, the two below that, Didymos and Dimorphos. I'll talk more about them later, but just to give you an idea of scale, those are really tiny, but Didymos is about half a mile in diameter. It's about 0.9 kilometers. It's between 8 and 9 football fields in length. And below that, Dimorphos, 0.2 kilometers. So it's about 1.5 to 2 football fields in, well, not length, but diameter. So I'll get back to those two asteroids later. But yeah, you can see there's a lot going on. that have actually been studied. Now, among the most interesting missions, in my opinion, one would be OSIRIS-REx. I'm going to talk about three. OSIRIS-REx was NASA's first and so far only sample return mission, or an asteroid sample return mission. So this is computer graphics image of the asteroid with a um, sample collector at the end of that probe about to touch the asteroid Bennu. So let's see if this is working. So hopefully you can see Bennu rotating. Excellent, excellent. The GIF works. So actual photos that OSIRIS-REx took a few years ago as it was approaching Bennu. And so this, ladies and gentlemen, is a near-Earth asteroid up close and personal. But if you want to get an even closer look, I've got one coming later. Oh, my timing was off. So Bennu's approximately the diameter of 6 football fields. It launched, OSIRIS-REx, I should say, launched in 2016. It interacted with Bennu for a little over 2 years, and it returned that sample. This is a robotic mission, returned the sample, almost 5 ounces of pristine asteroidal regolith. That's the dust and rocks on the surface of the asteroid. Almost 5 ounces, an unheard of sample size compared to some previous sample return missions from some other space agencies that just brought a few grams. So, um, and yeah, that's been almost 2 years now that we've had the sample, and scientists are still studying those, still studying the sample. So, since then, the mission has been repurposed from being OSIRIS-REx to OSIRIS-APEX. Some of you may be familiar with the near Earth asteroid Apophis. Many, many years ago, it was predicted to hit the Earth, an early prediction. And as the observations continued, astronomers gained complete confidence it will not hit the Earth, at least not within the next 100 years. But it will pass closer to the Earth than the satellites, the artificial satellites, our communication satellites, our weather satellites, and geostationary Earth orbit 22,300 miles altitude. It's going to be closer to the Earth than that. And it's going to pass by the Earth within that distance in April of 2029. So in a little less than 4 years. NASA had been planning to send OSIRIS-APEX to rendezvous with Apophis as Apophis is passing by the Earth. I cannot think of anything that would be cooler, let alone more scientifically important. But in the current proposed fiscal year budget, that project and many, many, many other science projects have been canceled. We'll see. We'll see what happens, because OSIRIS-APEX is still out there. So fingers crossed, maybe the money will come back for it. Planetary defense. This is science fiction. Just want to make it clear. I'm a Trekkie for life, have been since I was 8 years old. And when I found this image, I knew it had to go into one of my presentations, at least one. So, unfortunately, this is not the way we're going to be able to defend the Earth. This is where the term planetary defense comes from. Defend the Earth from near Earth asteroid impacts. We can't use the Enterprise, can't shoot it with phasers. We can't get Mr. LaForge. We can't ask him to help. Yes, this is the real LeVar Burton. This was not photoshopped. I had the privilege of meeting him at a space conference several years ago. So can't ask him for help. So we got to figure it out ourselves. One technique which has been discussed, you'll see some older techniques that have been around for a few decades, and you can kind of tell from some of the images before I get to some of the newer techniques. So having concentrated laser beams, I should say having laser beams concentrate on one spot, and using Newton's third law of motion. For every action, there's an equal and opposite reaction. So using laser beams to vaporize one point on an asteroid, a point so that the vaporized asteroid would go towards the Earth, meaning the asteroid itself would be pushed away from the Earth. So that's why the image is developed just this way. This is how you keep, this is one technique for keeping an asteroid from um, impacting the Earth. Solar sublimation, similar idea, but instead of using lasers, you concentrate sunlight on one point on the asteroid, vaporize the asteroid, and Newton's third law of motion, you push the asteroid in the opposite direction, and the asteroid doesn't hit the Earth. Painting an asteroid. It's generally understood that white, the color white reflects more light than any other color. So if an asteroid were to be painted, uh, then it would reflect more sunlight, and reflecting more sunlight means the sunlight would be providing more of a push to change the asteroid's orbit. So that's called the Yarkovsky effect. And again, it's an option. I'll keep going. Ion drive, and I'm going to interrupt myself because I'm checking the time. How much or how little more time do I have?
We can go a
Or
little
is
bit
my time
over.
up? I'm
Oh
sorry.
no, keep going if you're good. Yeah.
Okay, I'll keep going, but I'll speed up. Ion drive, get a very large rocket using solar electric propulsion to physically push an asteroid using the very high exhaust velocity, but extremely low thrust. So extremely low force, but extremely low force, but extremely fast force. So the exhaust velocity, the ions coming out of those engines might be going over 100,000 miles per hour. But since the push is extremely small, like the weight of, for example, two sheets of paper on your fingertips, you have that push at that speed for maybe 10, 20 years or more, and you can eventually change the orbit of an asteroid so that it wouldn't hit the Earth. If anyone saw the movie Armageddon, 1998, okay? Frank saw it. I don't know if anyone else did, but I don't even have to explain. Um, I'll just say nuke them. Now, from a science fiction perspective, that works. You can always blow up anything. Well, I won't get into science fiction, but the plan from an actual physics perspective is you would not want to try to detonate the asteroid itself, but you could use a nuclear weapon to detonate next to or beside an asteroid and have the force of the explosion push the asteroid in a different direction instead of blowing up the asteroid itself. And the reason for that is you wouldn't want to detonate the asteroid because instead of one, enormous space rock headed for the Earth, you could have a million tiny radioactive space rocks still heading towards the Earth. So your best bet is to push it, whether you use any of the previous techniques or nuclear, or I'll keep going. Another idea is the gravity tractor, and that's to have a large spacecraft maneuver near an asteroid, and the little wavy line that you see is invisible, but it's supposed to represent the extremely weak gravity of the asteroid and the even weaker gravity of the spacecraft interacting with one another so that the spacecraft pulls the asteroid gradually off course over a matter of maybe 20 to 30 years or more. So those are all options which have been considered. Here's one that's actually been acted upon. It's called the kinetic impactor. And I'll just keep going. It was acted upon with the NASA DART mission, the Double Asteroid Redirection Test. So, double asteroid, what's that about? I mentioned two asteroids at the beginning, well, a little earlier, Didymos and Dimorphos. Didymos being about a half mile wide, Dimorphos being quite a bit smaller. So Dimorphos is a moon of Didymos, or the moon of Didymos. So the DART spacecraft literally smashed head on into Dimorphos, slowing it down so that, as you can see from the graphic, there's the original orbit of Dimorphos, the white ellipse, and by slowing Dimorphos down, it orbits a little closer to Didymos. So you have the new orbit, which still comes out to the same maximum distance, but gets gradually closer before again coming back out to the same distance. Slowed the asteroid down, changed its orbit, so we actually have evidence. We have an actual test that proved that with a kinetic impactor, you can change the orbit of an asteroid. You can change the speed. You can change. Um, you can potentially keep an asteroid from hitting the Earth. Now, there are a lot of factors. Again, how large is the asteroid? How fast is it moving? What is it made of? All that has to be taken into account. But at least we have more than theories and calculations. We have some actual data. So this is artwork of the DART spacecraft. Oh, and there were CubeSats. Almost forgot to mention. It was at least one CubeSat, I should say, that had a camera that was watching DART as it smashed into Dimorphos and was able to watch the change in its orbit. In addition to every available telescope on Earth that was experiencing nighttime during the time of the impact. So again, here's DART. And this is what I was thinking about earlier. I was just a little early. So this is a GIF of Dart literally smashing into um, Dimorphos. And just in case anybody wants a more, I don't know, in case this isn't obvious enough as to, what smashing would look like, there's always this. If you want to smash, if you're in a Marvel movie or a comic book, you call this guy. All right. So here's another gift. And this is an upcoming mission by not NASA, but the European Space Agency. Hera will go visit the same two asteroids and get some up close and personal data regarding just how much that orbit of Dimorphos changed around the larger asteroid Didymos. And that's basically what I said here. It's already en route. It launched October 7th, 2024. And at the end of its mission, after about 2 years of studying from up close and personal, uh, the Hera probe will, I say, land in quotation marks on Didymos. It's not really landing, it's more of a rendezvous because the gravity is so extremely weak. It has to approach at like the slowest possible speed so that the probe will touch and not bounce off the asteroid and go back into space. So it's an extremely delicate maneuver. Um, and that's what's scheduled at the end of the mission. Asteroid mining. We're in the home stretch. So and no, nobody has spray painted property of X on an actual asteroid. All right. So there are a few companies in the US currently in business intending to either intending to mine asteroids or they already have equipment in space like Astroforge to whether it's studying asteroid, whether it's testing different equipment in space, with the intention of mining asteroids. So these are 5 U.S. companies, and here are 4 international companies. So the UK, China, Singapore, and Japan. So that last one, iSpace, they have they're partnering with the asteroid mining company, and personally, I'm a little biased about iSpace because the guy on the right, my friend Tony Stark, and here's another reference to Marvel movies. I call him Iron Man, and he's a regular. He has been a regular at the National Space Society's annual conference. This one was in Los Angeles in 2024, and proud to say I know a guy who's an engineer for iSpace. You know, turning science fiction into science fact. He's going to be mining near Earth asteroids. So now, mining for what? So there are, whether you're talking about meteorites or meteors, asteroids, there are silicaceous, there are metallic, there are carbonaceous, there are hydrated minerals. And you can see from each type of asteroids, what can you do if you're mining them? You can make glass, you can make structures using iron, nickel, um, platinum group metals. There are plans to there are plans to basically destroy the platinum market and crash the extremely lower the value of platinum if you bring in, I don't know, a few billion tons of platinum that you would add to the world supply, because we don't have billions of tons of platinum on Earth, at least not that's already been mined and refined. So if that were to happen, that company would have to just sort of ration, just slowly bring small amounts of platinum into the world's economy, so that they don't crash the market and it's not like worth as much as, I don't know, aluminum foil. So last one, hydrated minerals, water. If you've got a source of water in space, you've once process, purify the water, you've got water to drink, of course. You can separate water into hydrogen and oxygen. With that oxygen, you've got oxygen to breathe, and liquid hydrogen and liquid oxygen. If cool them, to cryogenic temperatures, those are the most efficient rocket propellants available. So, with a source of water, you can drink water, you can grow plants, you can breathe, and you can make rocket fuel. In conclusion, finally, there is an end. Um, the Despite the movie Armageddon, the threat, the risk of near Earth asteroid impacts is real, has been real, continues to be. So, my suggestion is we suffer the fate of the dinosaurs, or we find not two-thirds of the asteroids, but 90% or more. We find them, we continue to test how to defend the Earth from them, and potentially boost worldwide economies from the raw materials. The choice is ours. And that's the end. Any other questions?
Whoa, thank you so much, Ken. Yeah, I'm going to end it with a few that have come in here, and then we'll let you go. But thanks for the great presentation, first of all. That was a lot of fun and
You're welcome.
very
I
interesting
have
from my
fun giving
perspective.
it every time. It's just not even fair. I have more fun than you guys do.
Cool. Yeah, I'll hit up a couple that have come in here. So we've had a couple of questions about the new Vera Rubin telescope and the new objects that it's been discovering. Has that been sort of accelerating the pace of discovery in this field? And is the B1612 project taking advantage of that data?
The Vera Rubin, it's not intended, it's not like designed specifically to find near Earth asteroids. And okay, that takes a little explanation. Um, Asteroids, the best way to find them is to use an infrared space telescope, and the best location would be at that Sun Earth L1 point. So you can see asteroids coming towards and going away from the Earth. So that's not, oh, and the infrared wavelength has to be at the ideal frequency for finding near Earth asteroids at the temperatures that they are based on their distance, average distance from the sun. So, not saying Vera Rubin can't find near Earth asteroids, but that's not its primary intent. That's not what it
Mhm.
was built for. Um, the other telescope will the wow, the name has changed so many times. The Neo Surveyor.
Right,
That's what
right.
it's intended for, and that should really be game changing. Um, Now is Is Adam and Thor going through Vera Rubin data? My guess would be no, since Vera Rubin is relatively new. It's Adam and Thor intended to go through like historic data primarily. Not saying that it couldn't look at newer data at some point, whether it's the Vera Rubin telescope, um, whether it's or any of the other newer telescopes. The James Webb Space Telescope, for example, which is also infrared. But again, it's not intended specifically to find near Earth asteroids. It's not specifically looking at the ideal infrared frequency, but the potential is there.
Cool. Thank you.
Hmm.
And Massimo has a cool question. Maybe this would only work for metallic asteroids, but has anybody ever proposed using a giant magnet to try to deflect these things?
um, Giant magnet. I don't know if a magnet could be giant enough to
Hmm.
deflect something that might be moving at 40,000 miles per hour. I don't. I think you need a force much stronger than magnetism. Um, now, this is a joke, but I've got to say it because it's in my presentation. Anything weaker than Hulk, I wouldn't bother trying.
Well, gravity's pretty weak, right? We have the idea of gravity tractors, so yeah.
Hmm. It is. Once again, anything weaker than Hulk, I wouldn't try
All right,
it.
enough said.
Yep.
Cool. And a question of my own. So, on the topic of space, of asteroid mining, how do we
Hmm.
get those metals back to Earth without leaving a giant crater somewhere? Or is this more about building in space? Is that the real application here?
Both. Now, that's an excellent question. Yes, there would be materials used for construction in space. For what it's worth, whether it's mined from near Earth asteroids or mined from the moon. Now, as far as bringing metals to Earth, there have been a few different proposals that I've heard. One of them involved like cutting chunks of metal off the asteroid and letting it splash down in an ocean. But of course, you'd have to have some way for the asteroid to float, or a piece of the asteroid to float, so it doesn't literally sink to the bottom of the ocean. There have been a few different interesting theories. I don't know. I don't think there's been like total agreement on which plan will be the best. It's kind of like with planetary defense. There isn't one plan that for what can be done to protect the Earth from being hit. There's several plans. Different people have different ideas. So um, I think there's going to be some trial and error, and sooner or later somebody will get it right.
Okay, well, I hope the error isn't too bad on that one because
Yeah.
flinging stuff
Well,
at the Earth is scary. But
right. Aim for the middle of the Pacific where there's like thousands of miles away from any islands.
mhm,
And
for
and and
sure,
don't make the piece so large that it's going to cause a massive tidal wave. So there's some restrictions that would have to be in place.
for sure. Do you have time for one more?
Sure.
Cool, thank you. Rob Fleming has one that I wanted to touch on myself. What role can amateur astronomers play in discovery and tracking of near Earth objects?
Ooh, I'm going to say very limited. Again, jet black object against the jet blackness of space moving at 40,000 miles per hour. Now, if someone's got a telescope that's up to that challenge, because there have been some people, some amateur astronomers who have found near Earth asteroids. Now, I think it was um, they had cameras with time lapse, taking time lapse photos, so that when they looked at their photos, there was a streak which identified an asteroid, and they showed their data to the Minor Planet Center, which coordinates worldwide effort for finding asteroids and comets, and the Minor Planet Center identified the asteroid as something brand new that had never been seen before.
Hmm.
So, can it be done? Yes, but the odds are really low. It would involve a lot of luck, because most likely, what usually happens when someone takes a long exposure photograph and has a streak, it's usually something that's already been identified. Whether it's an asteroid, whether it's an artificial, whether it's a satellite, whether it's a big piece of space junk, the odds are it's going to be something like that as opposed to a brand new asteroid.
For sure. Yeah, I know the Planetary Society has like a grant program they do for that, but it's limited to people with like observatory grade telescopes. So you got to have a
Mhm.
really big telescope to qualify for that.
Exactly. And
Yeah.
those rarely find asteroids, as you've seen.
Hmm.
So
Sure.
yeah, compared to the fact that there's a million out there. We're up to almost 40,000, 4% with all those big telescopes.
Hey, it's better than zero. We're doing better than the
True.
dinosaurs already.
That's
So,
true.
yep.
That's true. We've got a 4% head start on the dinosaurs.
Awesome. Well, thank you so much for a fun presentation there, Ken. And if I ever meet you IRL, we have to trade LeVar Burton stories. That man is a
Oh,
saint. So, for
yes,
sure.
yes, he absolutely is.
All right. Thanks so much, Ken, and I appreciate your time tonight. You're free to hang out with us if you want to for the rest of the show, but if you want to get back to dinner, that's cool too. So
I
thanks so much.
I appreciate it. I actually will have to pass dinner, yes, because I have another meeting, a board meeting for National Space Society in 39 minutes.
All
So
right. Go, go, go. Well, thanks for running a little bit late for this here tonight. Really appreciate it. And thanks for the great talk.
my pleasure. Thank you all. Thank you for your patience and your great questions.
All right. Thanks so much.
I'll stop screen sharing
Yep. All right. We're
and
back.
all right, and I will log off. Okay.
All right. Thanks, Ken.
Good night,
Appreciate
everyone.
it. Good
Okay.
night. And I will start screen sharing and go straight into club news, assuming I don't screw this up. All right. I think that worked. Cool. Yeah. So, like I said, a whole lot going on. Historically, we used to skip the August meetings for CFAS because there was just nothing happening because it was the middle of summer. But gosh, that is just not the case this year. There's a ton going on right now. First of all, Geneva Dark Sky Night should be coming back soon. So we did renew our agreement with Seminole State College for use of the Geneva range out there for the coming year. So that's all been buttoned up. We're just waiting for the people to come back that we can actually do the actual scheduling with. So we're still working on putting that together, but they will be coming back. So stay tuned for details on that. Same deal as last year. We have basically 4 nights per month that we have eligible for. We'll just go with the weather and see what we can do. It also depends on availability of people to actually open up the gate there and oversee the event. So if you are interested in helping out with that effort, we can always use an extra set of hands, some extra gatekeepers, if it will. Contact Derek Demeter or observing at cfas.org if you are willing to step up for that. Also, I want to say a special hello to Jonathan Sasson, our new education chair. We're going to be hearing a little bit more from him later on. He's launching that mentorship program that you might have heard about today. So we're going to talk a little bit more about that. Also, welcoming Peter Lefevre, our new remote observing chair, which we're also going to hear more about later on. We've got a few cool images from our remote observatory in Texas that we are slowly rolling out to the entire organization. And he has been instrumental in making that happen. So thank you and welcome, Peter, as well. And like I said, the remote C-Star access is rolling out right now. We just rolled that out to the astrophotography subgroup in CFAS, in addition to the early adopters. And real soon now, we'll be rolling that out to the membership at large. There will be a training program basically required to learn how to use that. And there's a process for being certified and scheduling time on that out there. But we're working out all the kinks on that. And from a technical standpoint, it's actually working surprisingly smoothly. So we're working out the failure modes on that as well and how to deal with them. So thank you to everyone involved in that effort. Not just Peter, but also Wes and Chris and everyone else who's been involved in that. John Pinto for sure as well. Outreach is picking up again. If you remember last month, I said there was nothing happened. Well, that changed real quick now that school is back in session. The next one coming up in 3 days is at the Orlando Science Center for a Science Night live event. And then we got a whole bunch of stuff going on. The DeLand Regional Library on September 13th. The Orlando Museum of Art is having us back on October 4th for a daytime solar observing event that coincides with a astronomy themed exhibit that they have going on there at the same time. October 4th is also the International Observe the Moon Night, and we are hosting an event at the planetarium from 6 to 9 for that as well. So if you want to do both, you can head to the Museum of Art during the day and then head over to the planetarium at night and see both the sun and the moon up close and personal. That should be fun. October 9th, Rainbow Elementary is having us back for a outreach event there. And October 25th, another big date, we have both the Spooky Star Party at the planetarium happening that night, and also Orlando Science Center After Dark is happening that night as well. So depending on whether you're closer to Sanford or downtown, you might want to pick one or the other. Of course, Spooky Star Party is with our friends at the planetarium, so I might be a little bit partial with that one. If you want to help out with any of these events, head on over to the Outreach subgroup on Groups.io. or just reach out to outreach@cfas.org, which will connect you with Doug, our outreach chair. Also, holiday party planning is underway. Mark your calendars for December 20th. We're just waiting to hear back from Seminole State College for reserving the room that we want to get out there. We think we kind of outgrew that space next to the planetarium. We'll use it if we need to, but they have a much larger room, it turns out, that we're trying to get our tendrils into. So stay tuned for details. The main problem that we had last year is that we just had too many people. We couldn't fit them all into the space, and we didn't have the budget to feed everybody. So this year we're going to do it a little bit differently. We're going to have a bigger space, and we will have to charge a nominal fee to make sure that we can, provide you with a nice little catered buffet event there that has room for everybody, and we don't have to limit the attendance to that because we don't like turning people away. That's just not how it should work. More on that coming soon. Also, like I mentioned, John has launched the CFAS mentorship program. We're still kind of working out the details on that, but check your email. John Sasson sent out a note about how to do that. He created a little subgroup in Groups.io for mentorship, and you can just email him directly at education@cfas.org if you want to be a part of that. So if you are interested, do sign up. As you might expect, we have more mentees than mentors. So if you are an experienced imager or astronomer or if a observer, whatever your interest is, there is someone who wants to learn from you. So do please sign up if you have experience to share. And that is really cool. This is like super exciting because this is kind of like the main reason people join CFAS, right? They want to learn how to use that telescope they just got. They want to meet people. They want to have those one-on-one connections with fellow members. And this is a great way to make that happen. So very excited to see this happen. Thank you, John, for taking the initiative on that. And also, we have some new members coming in as well, too. Things are kind of picking up again on that front, too. Had a little bit of a lull during the summer because you didn't have a whole lot of outreach going on, but we have some new people coming in as we get out there again for the late summer, early fall season. If you are a new member, be sure to read that welcome letter that you received when you signed up. It has some important details on how to sign up to Groups.io. That is our main source of communication for the group, so do make sure you're getting those messages to take full advantage of everything that's going on here. And if you have any questions, by the way, that's the role of our board members at large. Both Wes Clem and John Pinto are at your disposal at BMAL1 and BMAL2 at cfas.org. They are basically the liaison between the membership and the board of directors, or feel free to just email me directly, president@cfas.org. That's cool too, whatever you're comfortable with. Like I said, we have some new board members coming on board as well recently. In addition to Jonathan and Peter, we also have Emily Chung joining as social media chair. So this is really, really cool. This is going to be a big part of our expanding the club, I think, improving our sort of footprint out there. She's been posting a lot more on our Facebook and Instagram pages, which you might have noticed if you're on those platforms. So do give us a follow on there. And if you have any social stuff to share, good, cool pictures, astronomy news, whatever it might be, do send it her way at social@cfas.org. And thank you, Emily, for stepping up on that too. In other news, elections are coming up before you know it. I think you saw John Pinto's note. He's the man in charge of making the election happen this year. Every year we do have to vote in a new slate of elected positions. And this time we have one or maybe two openings to fill. So the treasurer position for 2026 is going to be vacant. John Frank has decided to step aside and do other stuff and take on a different role within the organization. But the treasurer position is super important for the society. Obviously, it's kind of the lifeblood and how we stay solvent and compliant. So we are a small organization, so it's actually pretty simple as treasurer duties go within organizations. We only have a budget of a few $1,000s a year, so that puts us under the radar for more complicated paperwork and stuff. But if you're interested in stepping up for that, please do let John Pinto know. I know we've had one or two people already step up and say, hey, I can do this if you need me to do it. So thank you so much for the people that are considering that role. It warms my heart to see that happening. And in other news, I am moving to Los Angeles sometime in the not too distant future. And although it's been proposed that I could keep on managing from afar, I think the organization would be better off with a local president for sure. So if you're interested in stepping up for that position, also let John Pinto know as well. And again, we've had a couple of people step up for that as well. So I'm sure you're going to be in good hands no matter what happens there. And I'm not getting hit by a bus or anything. So I'll certainly still be in the background helping with that transition as it goes on. And hey, this is going to be my last term anyway. I'm already in years 3 and there's a 4-year term limit. So yeah, it makes me sad, but that's where we are. If you do have presidential ambitions, though, do let John know. I will be here, by the way, next month for the the in-person meeting at the planetarium. So I'll see you all there for sure and run the show for that. Of course, you are welcome to run for any elected position. The elected positions on the board are the president, vice president, secretary, treasurer, and the 2 board member at large positions. If any of those sound interesting to you, go ahead and throw your hat in the ring. Just let John Pinto know at bml2@cfas.org. We'll be presenting the final slate of candidates at the September in-person meeting and voting on that in October virtually because there's no in-person meeting in October. And if you want to learn more about those rules, feel free to talk to any board member to get the skinny on what it's all about. I think I'm being fair in saying that we have one of the more functional boards of directors in the organizations that are out there. So there's not a whole lot of politics or intrigue or anything like that. We're just a bunch of people who all want to make the organization better and kind of further our mission. And it's actually a very positive environment, I'm happy to say. So do consider joining if that is up your alley. Again, another note about our social media efforts expanding. So if you do have any photos you want to share, any events, or specifically photos from outreach events, those are specifically interesting, be sure to send those on to Emily or any news you might have at social@cfas.org. And speaking of astronomy events, we got a whole bunch of stuff happening in the night sky as well. It is summertime. That means that the summer Milky Way is out and all the nebulas that are in it. So for those that might be newer to the field, all these cool nebulas, these clouds of gas that you see glowing out there in deep space, well, they're not that deep. They're all within our own galaxy. So when the galaxy, the band of the Milky Way is in the night sky, that's when you can see all of these really cool nebulas as well. And these are really good for more light polluted areas as well, because if you do have these narrowband filters that really selectively let the light from these nebulas through, you can get pretty good images even from Orlando. For example, this one of the Lagoon Nebula that you're seeing here on the right. And the bad part about summer is that it is storm season here in Central Florida. And, sometimes clear skies can be hard to find. But we do have a remote observatory in Texas that we're going to be hearing a little bit more about shortly when we get to the Astrophotography Showcase. So if the skies aren't clear here, maybe they are in West Texas. And that's going to be your backup plan and a very exciting benefit to you as a member of CFAS. The Perseid meteor showers remain active for the next few nights as well. So if you're out there at night and got some dark skies, do look up. You might spot a few. Jason Higley has a nice little stream going on that he posts some snippets from once in a while on Groups.io. And he always catches some really cool meteors on that as well. And got a few more nights of that left before we wrap up that shower. No showers coming up in September that I know of as well. And the dawn sky, that's where most of the action is right now. So we have Venus rising in the dawn sky. Also, Jupiter is rising after midnight these days. So if you're up in the morning in the wee hours, that's probably what you're seeing up there. Saturn also is getting closer and closer to opposition, which is really cool. Mars is up, but it's not awesome. It's kind of low in the sky right now, and it's also pretty far away from Earth. So, but still, you can look at a red dot and say, hey, that's another world. How cool is that, right? We might even be going there someday. September 2nd is the first day of the month where Algol will be at its minimum brightness. That's kind of a cool star. It's a variable star, but it's not, from novas or anything like that. It's just what we call an eclipsing binary. It's actually 3 stars in that system, but the way it works is that there's actually 1 star going around the main star of Algol, and that happens every 2.87 days. So every 2.87 days, it has what we call like a minimum brightness. So you can watch that thing get brighter and darker pretty quickly as the days go on. September 2nd is just the first such date. If you want to keep an eye on that, you'll find the star Algol in Perseus, also known as the Demon Star, for reasons that I think are lost to time. It's been called that for hundreds of years, but that might make for an interesting little presentation someday. I think it has something to do with Medusa, like it used to be part of a constellation of Medusa's head or something. And the demon is a Gorgon or something like that. I don't know. I'll have to research that sometime. September 19th, the moon, Venus, and Regulus are going to be together in the morning if you want to see a pretty little conglomeration of bright lights in the sky. And something I'm excited about, September 20th to 21st, Saturn will be at opposition. So for you planetary imagers out there, that's going to be the best time of the year to image Saturn. That's when it's closest to the Earth and going to be the biggest and brightest that it gets for us. So that should be cool. As luck would have it, I have a business trip to San Francisco that day, but I'll try to capture that as close to that day as I can, at least. And also around that same time, Neptune will be at opposition. Neptune, although it's a big planet, it's very, very far away. So, even at opposition, it's not going to look like much more than a greenish dot in the sky. But it will be brighter than usual, so a little bit easier to find than it is normally. So lots going on in the sky these days. And that brings us to our astrophotography and sketching showcase. I'm going to lead things off with Pete Lefevre. And we're going to talk a little bit about the remote observatory out in Texas. And here are some examples that we're getting from the early data out there. Can you believe this is a sea star? My gosh. Peter, are you here with us?
I'm here.
All
You
right.
hear
Tell us
me
what we're looking
okay?
at. Yeah, we can.
Yeah. Yeah. So, like Frank, like you said, I think the telescope's been capturing data since around mid to late July. And, although we're gradually ramping up users, every night that the roofs are open at Starfront, the Sea Star is capturing data. So, we're going to see some stunning astrophotos in the next few minutes. But for those that are curious about already have a C star or curious about what's been set up by the club here at Starfront, here's kind of the type of image you can expect. With a night's viewing or a couple of nights worth of data. And so, some of the objects that have been visible from Starfront are represented here. The Cocoon Nebula, Dumbbell Nebula, these are all pretty familiar items. One that's less familiar is this SH2-86. That one's a bit tougher for the Sea Star to capture, and that's probably represents about 4 hours of integration time, whereas the Lagoon Nebula, that's about a little less than an hour, and same with M13. And the others are, 2 to 3 hours worth of data. But for sure, I think, we're gradually rolling up access to this telescope. But if you have a Sea Star, you've never used it in a dark sky location, you're going to be amazed. I mean, first time I saw it, there's no gradients on my image as after the first 40 minutes goes by. So, but also, if you're interested in longer exposures, Wes, who's been instrumental in the overall setup, along with all the other folks that got this up and running at Starfront, he's actually created a archive. So every afternoon after a night of this telescope capturing all of the data all night, he actually sweeps the Sea Star and archives all of that imaging data, and it's all indexed and directly. It's kind of like working like Telescope Live, kind of like if you're familiar with Telescope Live or one of these other um, astronomy sites. So all the data that's been captured since mid of July is available, and as soon as it's rolled out on a wider basis, you'll be able to download these images. And if you're interested in maybe not necessarily reserving a telescope for an evening, but if you're interested just generally in processing or learning how to process and getting better at it, this archive will also be available to you. And again, as every minute that those roofs are open, there's telescopes out there gathering data, and this archive that Wes has built is capturing that data. And once you make a request to get onto the access to the subgroup, it's maybe if you've used the Sea Star before, it's pretty quick. If not, there's some videos that John Pinto has put together that you can look at, get you oriented. You can then, I'll go ahead and work on getting you scheduled. We can just go through a quick certification once you've reviewed all the materials, and then get access to the subgroup and start looking for a slot on the calendar. But it's pretty interesting, whether you're new to astronomy or a accomplished expert. And right now, it's the astrophotography subgroup is the next rollout candidate that we're trying to get people onboarded. And our hope is that as they use the telescope, we might see examples from people that have a lot more expertise at post-processing than I do that can show us some of their handiwork, using this telescope. But again, I can't say enough about what the club did on getting this thing set up. I came in late, as a volunteer for the scheduling and whatnot, and it just really gave me appreciation for all of the work it took to make this thing a reality. I mean, it's pretty amazing.
Yeah, for sure. A ton of work went into this, and it's been amazing to watch the effort that went into this and to see the culmination of that work finally happening here too. Again, huge kudos to you, Peter, and also to Christopher Hunt for kind of like coming up with the idea and making it all happen. Wes has been instrumental in making all the back end scripts work, and John Pinto and kind of like making it all happen and making those training videos as well. So hope I didn't forget anybody there, but yeah, thank you so much. This is really groundbreaking stuff, by the way. Like, as far as I know, we're the only club offering something like this out there. And not only is this a really cool and unique benefit for our members, I think it's going to be a model for other organizations throughout the country to follow as well. So, well done, folks. This is really cool. Speaking of really cool, I did want to focus on one image from there. This is one that Isabel processed based on C-Star data. That's a dumbbell nebula, of course. And I mean, look at that. That's,
Yeah.
I mean, I've taken images of this, with my 8-inch scope, over like 20 hours, and it's not a whole lot better than that. I mean, it's just amazing quality that we're getting from those dark skies. And I'm pretty sure those aren't calibration artifacts, but that's some sort of like, dust surrounding it or IFM that I haven't even seen before. So really, really cool. I'm just
Yeah,
amazed at what these little devices can do.
yeah. The those are not artifacts. Actually, I've seen better processed images, probably with a bigger telescope, where these areas are also area of gases. And I was trying to get that pink and green to come out with that, but I was not able to do that. But those are not artifacts; they're actually gas around the nebula.
That is so cool. I mean, I can't believe a sea star is capturing IFN. That is incredible, and it's a testament to how dark the skies are out there too. Like that's just something that you cannot get under light pollution, no matter how hard you try. So, great job processing that, Isabel, and
Thank you.
it's just blowing my mind that we can get an image of that quality. Wow, thanks so much. Oh, hey, we got a whole lot more images to go through here too. So, Jason Roof. Oh my gosh, you here? I hope you are. This is that interstellar comet 3I Atlas. I see a Jason here. I don't know if it's that Jason though. If you're here, go ahead and come off mute. If not, I'll go ahead and read what you submitted earlier. All right, I'm going to read what you submitted earlier. So this is a tracked image of the interstellar comet 3I Atlas. And if you follow Avi Loeb, who was our guest a few months ago, you might think it could be an alien spacecraft, although I think the case for that is pretty weak. I could talk about that for a while, but I'll spare you. Anyway, he took this on the 12th of August using a Skywatcher 120 ED Esprit, a Mach 2 mount, and an ASI 2600 camera. Hey, that's a pretty cool gear there you got there. 16 70-second images were stacked and tracked on the comet using Tycho and APCC software. I'm not familiar with those, so check that out. Taken in highly light polluted skies and clouds over downtown Orlando. So even from downtown Orlando, you can track interstellar comets, it turns out. How cool is that? And yeah, if you did watch our presentation from Avi Loeb a few months ago, when you talk to him in person, he's very forthcoming that he doesn't really believe that these things are alien technology, but they could be. He just wants us to explore the possibility and be open to that instead of just automatically dismissing those ideas as being too crazy to consider. So keep that in mind when you read his stuff. Part of his argument is that because it's so close to the ecliptic at its angle that's coming in, that's a very unlikely angle to come in at. But you could say that for any angle, right? Like, for any specific, I could say that's unlikely for it to be 73 degrees as well. So yeah, that argument seems a little bit weak. But anyway, cool to watch this. This is only the one of the a handful of interstellar comets that we found. And now with Vera Rubin coming online, we hope to find many, many more. And do keep an eye on this, though. There are a few anomalous things about it. So maybe it'll surprise us. Maybe it will be weird. I hope it is, actually. That'd be exciting. Charlie Fink, are you here?
I am, yeah.
Yeah, what are we looking at here?
Well, this is obviously the Eagle Nebula.
Yep.
I'll never get tired of the awe of looking at the pillars of creation. I am, kind of relative newbie, and I don't have a lot of time on my hands, so I'm using the Vaonis Vespera Pro for these, and
Wow.
in my, Bortle 6 backyard. So
That's pretty sweet. You got your own little Hubble telescope there. That's the pillars of creation. How cool is that? And even cooler.
yeah, and yes, we were talking about how cool this has just been. The perk of being this far south, being able to see Omega Cen, which I love globular clusters in general, and there's nothing better than that one.
Yeah, it's like super low in the sky. Technically, this is a southern hemisphere object, so we should all feel very smug anytime we image Omega Centauri because it's probably the coolest globular cluster out there, and our friends to the north just can't see it. So take that.
I wanna say that was like 7 or 8 degrees above the horizon or something.
Yeah, and it still looks pretty clear, so that's a really good shot. Cool thing about Omega Centauri, it might not even be a globular cluster, right? Some people say this might be the captured core of a galaxy that collided with the Milky Way. So even neater. Love that stuff. Cool. Thank you so much. John Pinto, speaking of the remote sea star in Texas, I got a selection of objects here that you submitted. So do you want to walk us through these?
Oh, that's Andromeda there. Um, I think that was about an hour and a half on the Sea Star. And yeah, dark skies are our friend.
For sure. I didn't realize the field of view was that big, actually. So that
It's
fit
a
quite
mosaic.
nicely.
It's a
Oh,
mosaic.
okay. That explains it. Cool. Yeah, they have mosaic mode now. I forgot.
Oh
Even
yeah.
cooler. Speaking of dark
This
skies.
yes, this is definitely something be very difficult to get here.
Mhm.
This is called Barnard's E. Um, to me, it looks like a C in a bar, but hey, I'll go with whatever he wanted to call it. And I believe this is in Sagittarius.
Safe bet, given that it's the core of the Milky Way.
Yeah.
But yeah, like you said, these dark nebulae are really hard to pick up in the city.
And got Jar Helix. And again, the dark sky gives you that, 17 minutes. That's all you need.
Hmm.
I forget, I saw a graph that basically said, living where we live, you know, not, right in the center of Orlando, but in the suburbs like where I am and probably Frank, where you are, we're probably Bortles 6, maybe 5, but say 6. If you were to image for an hour, compared to a Bortle 1 site at Starfront, you get the exact same signal to noise ratio in
Mhm.
10 minutes. So
Mhm.
it makes a big difference.
For sure. Yeah, even imaging out of Geneva, like it's night and day just how fast you can collect an awesome image. And the Texas side is even better. So
Yep.
how cool is
Yep.
that? Yeah, I'm pretty sure it's Bortle 2 million where I live here right now. We're right next to Disney
Yes.
World.
Yes.
But gosh,
Bortle Disney.
yes, that's a new scale. What do you got here? Oh, the
Let's
propeller,
see.
I
Yes,
think.
this is the again, another one be very difficult to get anywhere else. What was funny about this one is I normally when I'm imaging using the C Star, I can use the C Star catalog to find pretty much anything. They have the whole Sharpless catalog. They've got, you know, the whole NGC catalog. This does not have a catalog entry, at least
Hmm.
that I could find. So I just had to get the coordinates and created a custom object inside the C Star catalog. So anybody else can now that goes onto Starfront can image this if they like. Just go down to custom objects and you'll see Propeller Nebula and you can go for it.
Cool. Cygnus.
Yes. This one actually was from my driveway, unbelievably enough.
Hmm.
But this was with the my S30. Uh, yeah, it says S30. Yep, my S30. And again, Mosaic tried to capture the entire Cygnus loop there. And it was very difficult. As you can see, it was almost 2 hours in my Bortle 6. And I really had to push the processing to even see the whole thing. But again, from Orlando, I was pretty amazed with a little 30 millimeter scope.
Absolutely.
And there's
North
our
American?
favorite North American nebula.
Yep.
Woo! And again, that was actually here from Orlando, with my 30. And again, I like the 30 for these wider field objects because you don't have to do such a large mosaic, so it goes a little quicker. But even with that, you know, as you can see, almost over an hour and a half from the driveway. It just blows my mind. I can do that just from my little 30 millimeter scope.
Absolutely. And is that the Cygnus wall there? Is that what that's called?
Yes, it is.
Yes, that's right.
I'm not sure if I sent you that one, but yeah, I did the Cygnus wall specifically with the 50. Yeah.
Oh, cool. Yeah, that's a good target to zoom in on if you have a smaller field of view. And the moon.
Of course, our favorite object in the night sky, except for when we're trying to image something else.
Yes, exactly. Yep, and observe the moonlight is coming up on October 4th. So, you know, give the moon a little bit of extra love. It's a whole world right above our heads, and we shouldn't take it for granted. But
That's
a gorgeous image there.
And I know a number of us would love to be an astronaut and go there one day. I know I was when I was a kid.
Totally. Yeah, it sparks the imagination. And you had a bunch more that you submitted that were awesome too. I hope you'll share those on Groups.io. But in the interest of time, I am going to move on. So thank you, John, for some awesome images and also another nice little taste of what we can get from our new Texas Observing site as well.
Thanks, Frank.
Yep. Alex Heppel, are you here? I don't think you are. All right. Well, I think Alex submitted a few shots that he made using his, I want to say it was a Nikon camera. I should have made a copy of his notes here, but a little example of what you can do with nightscapes here and not even having a fancy telescope, you know, just having a somewhat nice camera can actually get you some very nice shots of the night sky. As I said, the Milky Way is out and about right now, and that's what it will look like in a longer exposure. And all those nebulas that we're looking at are in there somewhere. So thank you, Alex. Oh, here's his notes. I have it on this slide, it turns out. This is from Moab, Utah. He was there a couple of weeks ago with another CFAS member to get some Bortle 2 skies under their belts. His mission was visual observation, and he did knock out a large chunk of the Messier catalog and some NGCs as well. He doesn't normally do astrophotography, but he couldn't resist. And oh my gosh, it wasn't even a camera. He just took this with a Samsung S23 Note, folks. This is just from a cell phone. Oh my gosh. It's so dark out there that you can pull that off just with your phone. So that's pretty cool. That's even in spite of a large fire that was going on south of Moab. So there was some smoke to fight there as well. He did visually manage to observe Saturn through the haze, he says, which kind of gave it a cool orange hue. But yeah, pretty amazing. That's just from a Samsung S23. Same phone I have in my pocket right now. Just whip that out in the good conditions and you can get a shot like that just with what's in your pocket. That's pretty cool. Speaking of cool, John Starr, oh my gosh. You know, speaking of what you can do with dark skies in Texas, tell us what we're looking at here, John.
Yeah, so this I can't shoot that here in Winter Park.
No.
It's just impossible. This is LDN 1251, the Rotten Fish Nebula in CFAS. And even at Starfront, which is where I took this from using my my telescope hosted out there, this is 38 hours of exposure. So I spent a lot of time. When that's a lot of fun out there. It's you can shoot sort of the popular targets and the bright targets very quickly. Which is a lot of fun and it's amazing to do. But there's some that what attracts me is there's some I just are impossible to shoot from here in Orlando. And so those are the ones recently that I have been shooting. I've had a monochrome camera and a filter wheel for years, and I think I had used the red, green, and blue and luminance maybe a half dozen times because I'm always shooting narrowband in order to get it. But this object is circumpolar, so it never dips below the horizon. And so there's always a time that you can sort of shoot it. Right now is really a great time. It is close to Polaris, so guiding can be tricky sometimes. But fortunately, I didn't have a lot of trouble with this one. What I think is particularly cool about this is that there's a couple galaxies in there. One that's right above sort of the fishtail. And that one that one is 107 million light years away. It has a really, really cool name, PGC 166755. And then there's one that's right all the way to the left, right at the tip of the nebulosity there, the dust. It's hard to see. Yes, that one has an equally cool name, PGC 69472, and that one is 86 million light years away. So it's a lot of fun when you see these little galaxies pop out. There's a couple others in here that I spent hours trying to find, and I could not find. I couldn't find any recording with them on there. So I'm going to do some work to see if I can't find some of the others. If you look closely, you'll see there's a couple on the right hand side, and yeah, there's one right there, and I haven't been able to find them. So. But anyway, I've been enjoying the dark skies, and for everybody using the Seastar, you're gonna love it. And if you haven't done it, I highly encourage you to do it. It's a lot of fun. You'll be amazed at what you can get.
Yeah, that is truly an amazing image there, John. Congratulations. I remember from your notes that you had way more time on luminance than RGB. Like, how do you approach the decision of how to split up that time?
So yeah, so I for dark nebula and stuff like this that's very faint, I spend a majority of my time shooting luminance, and I typically will only shoot a few hours in color, red, green, and blue, and I do that because you don't need a lot of time to get the color data. What you want to do is you really want, you want a signal to noise ratio that helps you reduce noise. And so I spend all my time on the luminance, and then I use the color data, the red, green, and blue, just to provide some of the color. And of course, the stars, I don't need more than 10 minutes on the stars. And so I will typically shoot the stars. I'll shoot 30 seconds. And I'll shoot 10 minutes worth of subs for the stars. And then I'll shoot 5-minute exposures for the red, green, and blue. But yeah, so what I've been doing, Frank, is for these dark nebula, I've been spending most of my time shooting luminance. And that wasn't a trial and error, honestly. I looked at what other people had done and talked to other astrophotographers that have far more experience than me, and asked them what they do and how they do it. And they've been great. And that's the thing about the Starfront community. They have a very active Discord server, and there's a lot of just fantastic photographers in there, and they're really great about giving you tips and stuff like that, and how to approach a target. So that's how I approached it. And then I will tell you though, I'm shooting a target right now where I'm dumping on 40 hours of hydrogen alpha just in order to get any of it, just because it's such a faint target. So
wow,
yeah,
I look forward to that one next time. That is awesome. Yeah, I look forward to getting my own rig out there sometime soon. That is some amazing results there. Way cool. Way cool. Thank you so much. Ray Gregory, are you with us? No, I don't think you are. Anyway, he submitted this shot here, and he did submit some notes. He says this is the Wishing Well cluster, NGC 3532. This cluster is located near Crux, 1,321 light years distant, and contains many binary stars. The binary star system HD 96755 within the cluster was first light for the Hubble Space Telescope on May 20th, 1990. So that's the significance of this little chunk of sky. He took this using a Teleview NP127 with an FLI PL23042 camera, I think. Software Bisque Mighty Mount. Hey, that's the same one I have. Astrojon LRGB filters, PixInsight for processing, and this is a collection of 5-minute exposures taken from, you might have noticed he said it was near Crux, so that might be a hint, Alice Springs, Australia is where that was taken. Love me some Southern Hemisphere images, so thank you for sharing that. Sharifa, check it out. We got the Trifid.
I do have the Trifid. So also just asked a question that I can go ahead and address right now. He was asking about the Seastar and doesn't really know what it is and how he can get one. So these images, I have 2 images that were taken with the Seastar at Starfront. So what we did was, as a club, for those that are not familiar, we sent a Seastar astrophotography telescope to a remote observatory out in Rockwood, I believe, Texas, and in Starfront observatories. And so as members, you can log in remotely and then be able to access the astrophotography telescope from Florida in Texas, and then be able to take images like the ones that you've been seeing. And so this is one of them that I took at the Trifid Nebula. Let me see, let me pull up the details because I took a bunch of them. So I planned it. This one was on the 17th of July, and I took one on the I think the 25th is the next image. And so both of them, I can't remember which one. I think it was the Trifid that I took on the new moon, and it was only 11 minutes, which is just wild to think about. And so, very minimal processing with this, and it's just neat how you can get these images from there. So, yeah.
Yep, that is amazing.
And then I have, this is the supernova that showed up. So you can see the core of NGC 7331, and then the supernova SN 2025 RBS that is just off the core. It's kind of hard to see on here, but if you zoom in, you can see it pretty clearly just off the core. And yeah, right there. And so that was 25-minute exposure. Same thing out at Starfront.
There we are.
Yeah.
Now I need to figure out how to zoom back out. There we go.
So
Cool.
I took a bunch more, but in the sake of time, I just sent these.
Any special processing on that? Because, I noticed the core of the galaxy itself isn't really blown out. So it's kind of got a good contrast there with the supernova.
Yeah, the only thing I did was just in Lightroom, honestly, and it was not much. And that actually, this is the one that I took, and it was a new moon, so I was just able to get it really clear. I would save the images every so often, and then past that, then they started getting blown out. And then this is not with the AI denoise feature. That just kind of blurred everything, and so then this is just the image as it is.
Cool. Thank you so much.
Sure.
Hey, Wes, you're up next. Oh, I love this. Definitely a seasonal image as we get closer to Halloween as well.
Yeah, I did image this one over the winter and spring. I just got around to processing it in July, I think. But yeah, this is the Ghost of Cassiopeia. A great example of dust and gas and stuff being blown away by a larger nearby star, giving it that pillory sort of look. This is the star Navi in Cassiopeia. And I think this one was a touch over 30 hours of exposure time, pretty evenly split between hydrogen alpha, sulfur 2, and oxygen 3. So
Awesome
this
stuff.
one,
And yeah,
very bright in hydrogen. I did several combinations, and they all just looked sort of weird, so I left it like a big, bright, red, fiery look.
yeah, well done. I mean, getting any color on that is a challenge. Like anytime I've tried to image that, it's just straight up red hydrogen. So that depth really paid off there. And yeah, it kind of gives that kind of like, glowy effect around the quote unquote ghost as well, which is also a cool little thing. It's like it's heading for the light there, if you will. So
yeah, it looks like it's going towards, but it's
the opposite. Yeah, it's being pushed away.
Yeah.
Yeah, very cool. Awesome job. Thank you so much. Bradley Plummer, are you with us? I don't think you are. Anyway, he submitted a shot of the moon here, a couple of shots of the moon. So thank you for sharing that, Bradley. And here's another even crisper shot of the full moon, our neighbor upstairs there and over our heads. So very, very excited to see that. I was reading an article recently that if you look at the moon the right way, you can kind of see a cow in it. And there's some speculation as whether that's where the cow jumping over the moon came from, because as the moon kind of like goes across the night sky, it kind of looks like it's changing its orientation. But something fun to think about there too. I don't really see it in this particular image, but sometimes from the right angle, I do. He also submitted this nice little nightscape. Again, just using sort of a camera that he had, not any fancy telescope or anything like that, but just an example of what you can do with the gear that you might have lying around already if you don't have a telescope already. So nice little shot of the night sky there and a starry sky behind a pretty little tree. And this, I believe, is probably Jupiter, based on how bright it is and the moons that are visible. Oh, I do have some notes from him here. He says this was taken using a Nikon D3500 with a 300 millimeter lens. And yeah, thanks so much. This was taken from 2023 through 2024. So thank you for sharing that. John Sasson. Oh my gosh, what do we got here? It looks like a shark.
Yeah, and it's actually a wider field of view from what John Starr had earlier. Right, I think his is what's shown here on the left side. So it's taking with my Red Cat 51 here in Florida. I went to Kissimmee Prairie, so about hour and 45 south of here, and kind of slept in my car to take this. But it was worth it. So this is about 7 hours with the one-shot camera. So it was my first time going there. It was fun, and this is something I wouldn't be able even to get from my house because of the trees, even let alone the light pollution. So it was cool to go out and get a target I normally couldn't get from home.
Gorgeous, gorgeous. Yeah, again, a testament to what you can do with dark skies. And Kissimmee Prairie is quite dark. I haven't been there in a while, so I heard they have like a new observing or imaging area, like just outside the gates now. Is that where you went, or was it actually at those pads inside the park?
No, it was at the pads.
Yeah.
It being July, I think I was the only one there taking images. There were a couple people just stargazing and getting drunk on the pad. It was just me, really.
Wow, that's amazing. Like, it's notoriously hard to get time out there, so that's, I guess, during the summer, not so much.
Yeah, right. Yeah, I mean, I had to take it down like twice because of rain.
Mm-hmm.
But it was worth it. I think.
Yeah, it paid off for sure. That's awesome. Thank you so much.
Hey, while I have the mic, I also want to say we are planning on our next in-person meeting at the planetarium. So before the actual main event, so around 3 p.m., I think Derek has volunteered to give an intro to astronomy course. So we'll be sending out details soon, but just wanted to put that on people's radar if you're interested to plan to get there earlier in the day.
Oh, cool. Breaking news. Thank you so much. And thanks for launching the mentorship program too. That is going to be a game changer for the organization. So much appreciated. Barbara Harris, I think you're with us.
Yes, I'm here.
It's our friend Tau Corona Beta.
I'm sure most of us know T Corona Borealis is a star that we've been waiting to go nova for the past few years and still hasn't. And so we're monitoring it. I do monitor it with photometry every clear night. But even on those nights where I can't do photometry, and you can do this too, is to just snap a cell phone picture. And every night, if you notice, there are some clouds to the lower right, and actually the whole bottom of this. So these aren't great skies for getting formal photometry, accurate photometry, but you can still monitor T-Core board by just taking a snapshot with the cell phone. And this is with my iPhone 16 Pro, 3-second handheld image. And if you take the image and then zoom in, which I have on the right, to the constellation, I've circled where T-Core board should be. And the limiting magnitude in this image is about 6.3 magnitude. So we don't see anything in the area of T-Core board that's 6.3 magnitude. So this information actually can be submitted to the AAVSO as T-Core board is less than 6.3 magnitude, so that we know it's not an outburst, because the baseline magnitude is about 10th magnitude, and when it does go into outburst, it should be about 2nd magnitude, which is the brightest star in Alpha Corona Borealis, which is the star at the bottom of Corona Borealis.
Right.
So, and anybody, I'm sure everybody out there has a cell phone, so they could snap a picture every night and look and see if there's any evidence of T-Core board going nova.
Yep. And for those new to the club, can you kind of give us the Cliff Notes version of how recurring novas work?
There are only about 10 recurrent nova that have been discovered in our galaxy. Like, novas are basically stars. They're not, the Latin word for nova is new star, and it's really not a new star. It's a star that's been there and is very, very, very faint. T-Core board actually is pretty bright for its baseline. But nova stars, they usually will go into an outburst where they become very, very, very bright. And most nova, they become bright and then they will fade back down to their baseline, and that's it. But we've discovered that there are 10 recurrent nova in our galaxy, where on a time scale of 10 to 50, 60 years or so, they are recurrent, meaning that they will get bright, they will fade, and anywhere from 10 to 50 years, they'll get bright again. So for T-Core Bohr, they found that that its period is about 80 years. And 80 years ago, if we go from the last outburst, 80 years actually would be in 2026. But someone who monitors recurrent nova regularly saw evidence that it was doing something strange and predicted that it might happen in 2024. So it didn't happen in 2024, but we do expect this to go nova. So it should be soon, and soon could be the next year or two.
Okay. So it feels like it's kind of late, but in fact, it still has quite a bit of window left.
Yeah, technically, if it follows this 80-year pattern, it shouldn't go until next year.
Really? I didn't know that.
2026. It's just that in 2015, 16, there was something strange going on with it. And they thought that it might go about 10 years after that. So that was back in 2015.
Mm-hmm. And Bill Castro, who's up next, by the way, has a question. Like, when it does go into outburst, how fast does that brightness increase? Does it just
a few hours?
Really? Wow.
Yes, a few hours.
That's going to be fun to watch. Hope it happens when we can see
it. That's why they want all eyes all the time on it.
For sure.
And then when it does go, I think it stays bright for about a week before it starts to fade again. So it rises sharply and it starts to fade sharply.
Very cool. All right. Thank you so much, Barbara. And speaking of Bill Castro, just a reminder, we're not all about astrophotography. You can sketch stuff too. We were talking about Saturn earlier, and here's Bill's sketch of Saturn from back in July. Bill, you want to talk us through it?
Yeah, sure. Here's a pencil sketch I made at the eyepiece of Titan's shadow transit on Saturn. And excuse that streak at the top of the sketch area. A gnat landed there and I smeared it off as I was brushing off some eraser residue. So the joys of observing in Florida.
Mm-hmm. For sure.
And I sketched this on July 18th. This was at 4:20 a.m. I used a 130 millimeter refractor at 284 power in my backyard in Oviedo. And the view was surprisingly steady. I could have used more power if I had it. The shadow was a small, very black dot. It was clearly visible. With the rings close to edge on, you could see the banding on the planet a little better than usual, as opposed to when the rings are spread out more. And the moons Titan, Dione, and Rhea were visible, and they're shown from lower left to upper right. And the Astronomical League posted this on their Facebook page that day that I observed it, and I gave the club some good press.
Yes, I saw that.
The thing with these transits, they happen roughly every 15 years when Saturn's rings appear approximately edge on. We just had another one on transit on August 3rd and again on the 19th. I think there's 3 more visible through October. And after that, you got to wait another 15 years.
Yeah, that's cool. I didn't make that connection. Like, of course, as the rings are more edge on to us, then we're going to see that plane of the moons intersecting it as well. So,
right.
Very cool. Yeah, and it's like 2 or 3 degrees right now, I think, of inclination, which is pretty small. So,
yeah, and pay attention to the banding on the planet, because without the glare from the rings, face on, it can really stands out.
Yeah, for sure. Like usually when we image Saturn, it's kind of featureless. You have to really process it pretty heavily to pull out those details, but a little bit easier now, perhaps. And as we get closer to opposition, it might be even better. So very exciting. Thank you so much, Bill. And that wraps things up, folks. Thanks for hanging with us tonight. I see most of you actually hung out for the entire 2 hours and 15 minutes. So thank you, everyone. It was a good show. We had a good speaker. We had some great pictures and some great news and activities happening within the organization. So thanks for being here tonight, and keep looking up. And I'll see y'all in person at our September meeting. All right. Take care, everyone. Good night.